Welcome back, Cubs, to our next edition of Chapter 8 lecture notes. So on the screen, as you can see right now, under topics there, you're going to want to go to Chapter 8. And then you can follow along with the Chapter 8 lectures here. You're going to want to review those on your own as well. But let's just before we get into the lecture, let's briefly talk about this topics page here. So in class, this is what we're doing on that particular day, and then this is the homework that is due on that particular day. So for example, Monday, the homework, join the Remind class. About 27 of you have joined Remind so far. Let's get that number closer to the 72 of us that are in this class. I'll periodically send updates and quick notes on there. Also, if you need instantaneous feedback, you can also shoot me a Remind. But emails is still the preferred method of communication, but Remind can help with that instantaneous type stuff. So as you see, there's no homework due until Wednesday, the Chapter 8, Section 2 review. So that's going to be listed under assessments. I know for the last one, we had you take a picture and then upload it. We're going to try using this assessments feature so that we can get more of those assignments in on time. It's due by 3 p.m. The key will be posted after 3 p.m. So after that, there's not going to be really credit available for you. If you need an extension, of course, email me. So let's jump into the Chapter 8 lecture here. So the second section, this along with balancing equations, this is kind of the bulk of the chapter. So once you have down the balancing chemical equations, and if you want more practice, we've got this link on the side here that takes you over to Mr. Carmen's blog, where you can do some balancing equation practice if you want. So the balancing along with Section 2, this is on types of chemical reactions. This is the bulk of Chapter 8. So there's 5 different types of chemical reactions: synthesis, decomp, single replacement, also known as single displacement. You can use either interchangeably, double displacement or double replacement, and then combustion. So synthesis, just like you would think, synthesizing something is bringing parts together to make a whole. So we have A plus B yields AB. So chemical A plus chemical B yields chemical AB. So the general equation here for that is A plus X yields AX. Now these examples listed here for the synthesis reactions, I highly recommend taking a look at this Predicting Products Quick Reference sheet. So this particular sheet here, this gives you the types of chemical reactions and predicting the product. So it gives you the general equation and then the different types of examples. So get familiar and comfortable with this worksheet. This handout. You can use this handout on your quiz, on your homework, and the upcoming exam. So get comfortable using this because your answers are right in here. Also, don't forget, we still have to know how to name things. So if you need to go back to the last chapter for naming, make sure you review the naming there. Because we need to know, like chlorates, for example, and carbonates, nitrates, nitrites. So we need to know how to do the naming. So continuing on after synthesis, we've got the decomposition. If something decomposes, it breaks up in 2 parts. So the general equation is AX breaks down into A plus X. Now, there's a couple different ways that we can break down substances. They can decompose from heat. They can decompose from light. They can decompose from electricity. Binary compounds are going to be broken down into 2 simpler elements. So silver oxide breaks down into silver and oxygen. Notice the coefficients. We have a balanced chemical equation. Make sure you can balance, guys. Continuing with decomp, a metallic hydroxide like calcium hydroxide breaks down into calcium oxide and water. Lithium carbonate. Carbonates break down into carbon dioxide and a metallic oxide. So lithium carbonate breaks down into lithium oxide and carbon dioxide. So anytime you have a metallic carbonate, it's going to be producing carbon dioxide. Metallic chlorates. So here we have potassium chlorate decomposing into potassium chloride and oxygen gas. So we saw this in class actually. If you recall, we heated up some potassium chlorate and we heated it up very high to boiling, and then we dropped either an M&M or a gummy bear or some piece of candy in there, and then we saw the huge flame and whatnot. Because of the excess oxygen produced when a metallic chlorate decomposes, that allowed that combustion to give that nice bright light that we saw in class. So here are some other examples of decomposition reactions. Metallic oxides break down into a metal and oxygen. Nitrates decompose into nitrites. Notice the subscript here. We have a nitrate, NO3, decomposing into a nitrite, NO2. We still have the metal combined with it, and it gives off oxygen. We can also break down acids to form a nonmetallic oxide, which is carbon dioxide, nonmetal oxide. Carbon dioxide is a non-metallic oxide, and then water. After decomp, we got single replacement. So single replacement is when one element replaces another element in the compound. So A plus BX yields AX plus B. So notice what we have here. The A replaced the B. It took the spot of the B, and now we have AX and B was kicked out. So when we're doing single replacement reactions, it's important to remember that cations replace cations and anions replace anions. I'll say that one more time. Cations replace other cations and anions replace other anions. So cations replace cations. In the case of a metal replacing a less active metal, here we have M plus Bx, with M being the more active metal, it comes in and it kicks out that B metal to then form a compound Mx plus B. We have the example here, iron plus copper to nitrate yields iron to nitrate plus copper. Copper got kicked out by itself, so it's a single replacement. One element, in this case copper, was replaced by the iron. Notice there's no change to this polyatomic here. We still have NO3. And then halogens. Halogens, because they are anions, will replace other anions. So here we have chlorine replacing bromine. So if chlorine takes the spot of bromine and kicks bromine out, we have sodium chloride, and the bromine was kicked out. Now, when we predict products, you want to write down the chemical formula correctly first, then balance the equation. So when we write this out, we would end up with NaCl plus Br2. Well, that's not balanced, so then we have to go back and balance the equation. So predict your product, write out the correct formula, then balance the equation. So here we have some other single replacement examples. Just a reminder, you can find these single replacement examples here on the Predicting Products Quick Reference Sheet. Once again, select that. Here we have two windows of the same document. Use this document. Get comfortable with it, guys. Okay, back to after single replacement or displacement, we have double displacement or double displacement. So the general formula here is AB plus CD yields AD plus CB. So this is kind of similar to when you foil, inner combining and then outer combining. So what's going to happen is the A is going to combine with the D. So this cation A combines with the anion D of another compound to give us AD. The outers combine, the cation and the anion. And then B and C will combine. The C cation from this compound will combine with the B anion of the first compound to give us CB. Remember, cations are written first and anions follow after that. So double displacement, double replacement. What we have is reactions in which two compounds are going to swap around their cations and anions. So this could happen through neutralization, a gas-salt reaction, forming a precipitate. And if you go back to that worksheet listed right here, you will have examples of, for the third window, you will have examples of double displacement reactions. So remember this general equation here, AX plus BY yields AY plus BX, where A and B are cations and X and Y are anions. It's important when you're writing these new formulas that you write down the compound correctly. Otherwise, you'll get the wrong answer. We don't want that. So let me close out of that. Oh, one more. There we go. So there's the double displacement. And lastly, one of my favorite types of reaction is combustion. So combustion reactions, burning or reaction with oxygen, produce heat and usually light. So here we have a hydrocarbon. Now remember, in science, if there's a word that you don't know, break it down into usable parts. Hydro for hydrogen, carbon containing carbon. So it's a carbon-hydrogen compound. Sometimes oxygen will also be involved in the organic compound, but for us right now, it's usually going to be just carbon and hydrogen. So carbon and hydrogen react with oxygen to form carbon dioxide and water. So anytime you see a hydrocarbon plus oxygen, the products will be carbon dioxide and water. Remember, we want to predict the products, then balance the equation. Just a note, incomplete combustion, sometimes that'll occur if we don't have enough oxygen there, and we'll get the production of carbon monoxide, or particles of just carbon soot instead of the full reaction of carbon dioxide. So this chapter, there's a lot there, guys, so it's important that you are reading and outlining on your own, and then also reviewing those notes. If you take a look at the topics page, I posted another video from another science teacher here in Michigan on chemical reactions predicting products. So that will walk you through how to predict products in addition to this video and reviewing those lecture notes. Now for Wednesday, what I'm going to do here is I'm going to post over here walking through a couple of these problems, and I'll do the same for the practice worksheet that's due on Thursday. Then on Friday, we'll have a quiz on predicting products. Wednesday, let's try something new. We're going to do a Zoom meeting. That's an optional Zoom meeting. You're not required to attend, but it'd be great to see all of you, and you guys can ask questions in real time, and I will use the document camera to walk you through any questions that you have, and just check in and see how you're doing. We'll also do a reading of Paddle Whispers on Wednesday during that Zoom meeting too. So you can see period 3 will start during that class time, period 6 during your class time, and period 8 during your class time. If you're unable to make one of your class times, let's say you have a quiz or a test in another class, you're more than welcome to join one of the other periods. But if you can, please join your normal class period for that Zoom meeting. Okay, guys, have a great rest of the day. Let me know if you have questions. Don't forget to use your email, Remind, and also the discussion board. So that discussion board can be found under the assignments. It's a little bit different view than you guys, but Chapter 8 discussion board right here. Go ahead and use this discussion board. If you're having any issues with it, let me know. We've got answers to previous homeworks there. We've got responses to students. So if you got questions, you can post there too. Okay, have a great day, Cubs.